So if you are to draw the electronic configuration for this, I will start with the central atom, which is carbon. 1, 2, with 4 valence electrons. 1, 2, 3, 4. So let's make this also done with that explanation. So if you pair it up, 1 hydrogen, the other, this again, and then this. So you can see now, it's looking as if each of the hydrogen has their atom shell filled up, and with the carbon also filled up, right?
Yes.
So, like I said, that means it exhibits covalent bonding. That is the type of bond present here. Then, how many lone pair do we have?
No one.
0. Shared pair?
4.
4. Thank you. So you deserve a month, but I can't give you.
I think you deserve it more because I've never really understood this topic like.
Yeah, okay. So let's see what next. Okay. Are you with me now?
Yes.
Okay, let's look at one question a little bit before I move on. It's actually a why question here, and I love it. Okay, and when element Y, are you with me? Are you there? Hello?
I'm here.
Okay, just write this question down. The compound form.
Yes, hello?
The compound form, write the question. The compound form between X14. The compound form between X14 and Y16 is dash. Are you there?
Yes.
Is dash. So the question is, what is the compound form? In terms of the options I have here, maybe let me give you options to understand better. A, X, Y. So these are the options now. S and Y. B, SY2. SY2. C, S2Y. S2Y. And D, S4Y6. Do you understand? Are you there?
Yes, I'm here.
Okay. So that is the question. Which of the following? So let's, do you understand the question at all?
Not really.
Okay. So what you do in this situation, you let the students write out the electronic configuration. That's the first thing to do. So S being 14 will be 284. Then Y being 16 will be 286. That's taken.
Okay.
So the question they are simply asking them now is this: how many X and how many Y will combine together? Do you understand now?
How many X and how many Y?
Yes. Will combine together. Do you understand the question now?
Yes.
Okay, let me break it down for you again. The Y has 6 valence electrons. Needs how many more to be stable?
Needs 2.
2 more. Very good. X has 4. It needs 4 more to be stable. Or it gives out that 4 completely.
Yes.
So if S give out is 4 to Y, it becomes 10, which is more than enough. Right? So that means, let's look at it this way. I have another S again, or Y rather, 286. So that this one needs 2, this one needs 2.
Okay.
2 plus 2 will give me 4. So that means this Y will now be like this. X will share or give out its electron 2 first to one Y and another Y again. Are you with me? So at the end of the day, I need 1 S and 2 Y to combine together. So the answer becomes Option B, SY2.
Okay, okay. Wow.
So that is it. This is just one question. If you are done with it, let me know. So I will look at another one again. I have a lot of them here. I advised the last time that we should get grade 50 to help teaching the students. I use it a lot. So in any topic I'm teaching, I would have ample questions from WAEC on that particular topic. We'll answer it, and then the students know whichever angle they are coming from when they're answering questions, they know this is where the examiner is going to. So it's better. It's not much. The book does not cost about 1,000 naira or so. For 50. Yeah, it will help you. Are you ready now? If you are ready, let me know so I can look. Let me read out the next question.
Yes, I'm ready.
Okay.
Ready.
Okay, you can write down. This is the next question. Element X with electronic configuration 282. Element X with electronic configuration 282 and element Y with electronic configuration 287 are likely to combine. Are you there? Are likely to combine by dash. A, metallic bonding. B, covalent bonding. C, electrovalent bonding. And D, dative bonding. You're laughing. Just a minute. Did you get the question?
Yes.
Okay. Now, if you are finding it difficult to answer, it's also very simple. What is the electronic configuration of X? What is the electronic configuration
is it covalent?
Let's do it together. No, I will tell you now if you are right or wrong. You will know. Don't worry. What is the electronic configuration?
Okay, yes, it's 28.
28 what?
282.
Okay, thank you. 282. What about Y?
Y is 287.
287. Okay. Is S a metal or a non-metal?
S is a metal.
Okay. Then Y is a what?
A non-metal.
Okay. What type of chemical combination exists between metals and non-metals?
It's ionic.
Answer is ionic. That's the answer. Either ionic or electrovalent is the answer.
Okay.
You see how they got the question part again. This is a different question. So let the student know also that. Then, assuming you were asked to write the formula of the compound form between X and Y, what will be the formula? To write the formula form between elements X and Y, if they combine, what do you think will be the formula?
To be
how many X and Y will combine?
SY2.
SY2. Thank you. That will be the formula as well. SY2. As simple as that. Then the student know the difference between SY2 and Y2X.
Okay.
Even though it looks as if the things are equal, it's wrong. This will be wrong because you are writing the non-metal before the metal, which is wrong. So that is okay with that. Are you
okay? Metal comes before non-metal, right?
Yes, the metal is always written before the non-metal. So it is SY2, not Y2X. Is that taken?
Yes.
Okay. Now, let's quickly look at one more thing. One of the things they might also use to ask the students is that to list the properties of ionic and electro or covalent compounds. So because of time, we'll do it side by side. You can just do it like a table, but when you're teaching the students, not like this, but you can just also give them as a summary like this. You can write this ionic compounds. On the other hand, you write covalent compounds. Are you ready?
Yes.
Okay. Then under ionic compound.
Yes, I'm ready.
Okay. Under ionic compound number 1, you can write number 1. They have high melting and boiling point. High melting and boiling point. Is that taken?
Okay.
Then do the opposite for covalent.
Okay.
If you have done that, let's look at another one. Ionic compounds are usually solid in nature. That is number 2. They are usually solid in nature. That is for ionic compound. Then for covalent compound, you can put the opposite, not usually solid. Take it. Is that taken?
Yes, yes.
Then number 3.
Yes, sir. Yes, sir.
Okay. Number 3, ionic compounds are soluble in water or polar solvents. They are soluble in water or polar solvents. Then the opposite will be for covalent. They are soluble in non-polar solvents or not soluble in water. If you are ready, let me know. Let me point out one more.
Please, for the number 2.
Yes.
The difference, number 2 difference. You said the ionic compounds are solid in nature.
They are usually solid in nature.
Yeah. What about the covalent?
Opposite. They are usually not solid.
Okay.
So it's always very simple. Opposite of this becomes the other one.
No.
Then for number 4, you can put them any way you want to number it. Anyone can come first. Does not matter. Then ionic compounds are they are good conductors of electricity in molten states. They are good conductors of electricity in molten states. Is that taken? Are we ready?
Yes.
Okay. Then opposite is for covalent. Opposite is for covalent. How many have we written now?
4.
Let's just add one more to it. Let me think of anyone I can remember at the moment. Did we say they are good conductors? We have done that, right? Soluble in water, we have. Solid in nature.
Yes.
Okay.
Yeah.
They are ionic compounds as crystal structure. That's another one. Ionic compound as crystal structure. Maximum they can be asked in the exam is 3 in most cases, and at least they should know 3. Are you with me?
Yes.
Okay. So don't need to write. So let me just tell you why I'm pointing out this. Look at the question here. It said state 3 differences between electrovalent compounds and covalent compounds. That's a WAEC question, 1992. Then they also asked the same question again in 1998. Then are we ready to go? Are we ready?
Yes, we are ready.
Yes, we are.
Okay, I want to give you this question. Maybe you tell me the answer. 3 elements, A, B, and C. Capital letter A, B, and C. 3 elements, A, B, and C, have atomic numbers 8, 11, and 12, respectively. A, B, and C has atomic number 8, 11, and 12, respectively. Write the formula of the compound formed by chemical combination of A and B. Is that taken?
Please come again with right.
3 elements, A, B, and C, all capital letter, have atomic numbers 8, 11, and 12, respectively. Write the formula of the compound formed by the chemical combination of A and B. A, B, and C. 8, 11, 12 in terms of electronic configuration or atomic numbers. You are now asked to write the formula of the compound formed by the chemical combination of A and B. Formula of the compound formed A and B.
A to B.
Okay. Just A will be 2, 6. B will be 2, 8, 1. Madam Agatha, are you there? So if that means I will need 2A or 1A rather. Is it 1A? I will need 1A and 2B. Do we agree? Because if one comes,
Yes.
I will need another one again. So I will have another B again, which is 2, 8, 1 coming here again. Because these ones, the B is the metal. So that would be B2A, not A2B. So this will be the formula of the compound form, B2A. That means 2B combining with 1A. And it is B first because the B is a metal, while the A is a non-metal. Are we okay? Madam Esther, can you hear me?
Yeah. Yes, I can hear you.
Okay. So quickly, let's go to the last that we are going to end now. Dative or coordinate combination. So in this aspect, I always teach my students. Before now, I taught in a boarding school. Yeah. So it's easier when I'm teaching them this aspect. They can easily relate with what I want to say now. If you have ever taught, or maybe you went to a boarding school. So you know, students in boarding school, most times they go with provisions, depending on the boarding school. And there are some set of students, even when you in university too, you have friends that you always visit. Whenever they come and visit you, it is only to come and eat your food. That's the reason why they come and visit. They will never contribute to the cook or to the meal. They will never say, guy, I get 100 naira today, or I get 1,000, take, cook something more, eat. No, it is, guy, what do you get for us now? Every time. They are always benefiting, but they have no business to contribute to the food when it is placed on the table. That is in case of coordinate combination. In this type of combination, only one atom is contributing the shared pair of electron, while the other one has no business contributing. Rather, it wants to attain a stable configuration. Did you get that? Take, for example, the case of...
Sorry.
Yes. Did you get that? Take, for example, the case of ammonium, which is NH4. Remember, we have NH3. NH3 is called ammonia. And we treated this one before. Are you there?
Yes.
So, in the case of ammonia, the type of bond that is present is covalent. Why? Because everybody is contributing. Nitrogen is contributing, hydrogen is contributing. But in the case of ammonium, if you do a very simple calculation, nitrogen has 5 electrons. 1, 2, 1, 2, 3, 4, 5. That is 5 valence electron, which is 2, 5. This is nitrogen. Then hydrogen being 1, 1, 1. This is like ammonia now. It will come here, yeah, and then this other one comes here. So if you look at it, everywhere is filled up. Which will now give me like these 3 now come here become 2, 8. But in the case of ammonium, which is NH4, we have 4 hydrogen. So if that other hydrogen, which was still like this, have something where will they attach there, it's going to be more than enough. So which means that in the case of ammonia, one of these hydrogen is an empty shell. It does not have anything to contribute, but rather it does not have anything, but still want to attain its stability, like in the case of every other hydrogen. So you will now see it attaching itself here. It did not contribute anything to this guy, but it's still attaching itself here. That is what is present in ammonium molecule. So a molecule of ammonium has what we call coordinate covalent bond. That is the type of bond present in ammonium.
Please, can you explain that one again?
Where exactly? Is it for the ammonia or the ammonium?
The ammonium.
Okay. Ammonium has NH4. On a normal day, this is ammonia with all its atomos shell already filled up. But ammonium has 4 hydrogen combining with 1 hydrogen. So if assuming I have it like this hydrogen now being the 4th one coming here does not have anywhere to fill up again, because if it comes here more than enough, it will not give me 9. So which means that one of these hydrogen from this ammonium is an empty shell like this. It does not have anything. But even though it's an empty shell, it still want to attain stability like this other hydrogen here. So what it will now do here is that it will come here and attach itself to this place, which is already filled up. So looking at it now, you think it's filled up too, but it didn't contribute anything here. So in that type of situation, it is covalent or coordinate covalent combination. So by definition, this is a type of combination whereby the shared pair of electrons is contributed by only one of the atom, which means that ammonium molecule is formed between NH3 plus H plus. On Monday, Chemist Obie said something about this. This H plus means that hydrogen is 1 valence electron, but that one is already gone because of this plus. So that means it's the empty one. If it attaches here, it becomes 4, which you are seeing here. Do you understand it now? So in most cases, you see it as this. In terms of representation, you see an arrow. Whenever you see in objective, this is what the students mostly see in objective questions. You will now put something like this. And now see what type of bond is present here. In a structure like this, it is coordinate bond or dative bond. This arrow points to the fact that this is the hydrogen that did not contribute. That is where that arrow is pointing to. Have I answered your question now, sir?
Yes, sir.
Okay. Madam Esther, do you have any question too as regards this?
No, sir. Thank
Okay. Okay. So then lastly, if I have a compound such as ammonium chloride, what is the formula for ammonium chloride? I'm shutting down now. The next 10 minutes to round up. Ammonium chloride.
NH4Cl.
Okay. NH4Cl. Good. And the student can ask, because this is a theory question, name the type of bond present in ammonium chloride. Ammonium chloride has, first of all, it has ionic combination. It's inside this ammonium chloride. Covalent combination is also inside, and then dative combination. So a molecule of ammonium chloride has these three types of bond present inside of it. Any issue? Hello?
Yes, you are with
Sorry, I
you.
understand this part too.
Okay. So ammonium chloride has three bonds present. Inside the molecule of ammonium chloride, we have ionic bond. We also have covalent bond. We also have dative bond. Why do we have that? NH4 is dative bond. And NH4 is formed by NH3 plus H plus. This NH3 is covalent.
Yes.
Are you there?
Mm-hmm.
Then NH4 with a Cl is ionic. So these three bonds are present in the molecule of this. We have ionic, we have covalent, and we have dative. This is an exception to it. This is one question they always used to ask them. Identify the type of bond. They'll give very simple ones and then end it up with this. Like to cap it up. I think I'm okay with this now. So I have these questions here. Name the type of bond that exists in each of the following molecules. Are you with me? The first one is CaCl2. What type of bond is present? This is a wide question. Name the type of bond or bonds. They put it there so that in case if it's more than one, list all of them. Name the type of bond or bonds present in each of the following molecules. 1, CaCl2. 2, NH4Cl. 3, CCl4. I think, yes. So, can we go now? The first one, what type of bond is present?
Ionic.
Ionic, thank you. Ionic. Or, so when you're teaching your students, sometimes, last week I was given, after marking, they gave me my practice form to fill. And I'll begin to wonder why. To them, maybe they put the student, I don't know, but remember, if you are the only teacher teaching your students, there are sometimes that all the students will have tendency to write the same thing because you actually taught them the same thing. But also try as much as possible to give the students varieties. Like some set of students can write ionic, some students can write electrovalent. It's the same thing. So either ionic or electrovalent, but not ionic and electrovalent, please. Let them also know that one. Then for ammonium chloride, what is the bond present? Ionic, covalent, and dative. That's it. Hello?
Yeah. So you have to be 3 for that one.
Yes, for ammonium chloride, you list all of them out. That's why they said list the type of bond or bonds. They themselves the question know that they are situated by it could be more than. So list all of them. If it's more than one, list all the bond that is present in that particular one. Then for the last one, CCl4. What type of bond? Remember you told me that this was the aspect you're having issues with, so I want to be sure that I've did justice to it before I round up. I'm waiting.
No, you did not teach me. Oh.
I thought you. Okay, let me see the time. How many minutes? I have 4 minutes to go. Carbon is 4. Do you agree?
Yes.
Then chlorine 287, but it is 4. Another 287, 287 with another one again 287. So this one needs 1, 1, 1, 1. It is not wise to give out all these ones. So rather, it will say, you come, let us share together, let us reason together. So if you draw the structure, the carbon.
Okay, that makes it covalent.
Yes, that's covalent. See now. And I taught you. 1, 2.
This one.
1, 2, 3, 4. That is the structure for carbon. Then for this chlorine now, you will now see it coming here. You can put in bracket 2, 8. The other one now will be 7. 1, 2, 3, 4, 5, 6. But this 7 that makes it is coming from here. The same thing for others. So at the end of the day, chlorine is balanced. Join all of them is balanced. They have shared, which is covalent. Taken?
Yes, taken.
Okay. Until I'm sure that you can answer 1 or 2 before I will go. Tell me this one. What type of bond is present in 1, MgO? MgO. That is magnesium oxide. MgO, NH3, H2S, NH, H2, MgO. I'm just listing as many as I can before the time goes off. I've written H2S, no. H2X, NH3. So what type of bond is present? We have time, 2 minutes to go. What type? Can you hear me?
Yes, okay. You.
The voice is not very faint.
It's not faint.
Okay, so NaH 281. Hydrogen 1. What type of bond? This one will come here. It becomes, for the hydrogen will now become 2. It's balanced. And then this one now become just 2, 8. So this type of bond is ionic. Do you understand it?
Yes, it's
Okay. Then H2. H2 means 1 H with another H. 1, 1. This one needs 1. This one needs 1. Guys say, oh boy, come, let us reason together. They share covalent. I'm trying to be fast to finish it before the time goes up. Then we have MgO. If you look at it, magnesium is 12, 282. Oxygen is 2, 6. This 2 goes to this guy. Transfer. Ionic. Any question?
no question.
Okay. Then H2S, which is sulfur. Sulfur is number what in the first 20 elements? Can you please help me? My memory serves me right now. At this point, my student will say, okay, I had a blackout.
Now
What is the number of sulfur in the first 20 elements? Number what? Is it 12?
16.
16. Okay. That is 286. And we said 2x. That means 1 H
Yes.
and another H. So what type of bond here? I'm going to draw the outermost shell of this one now. 1, 2, 3, 4, 5, 6. With a 2, 8 inside. 1 hydrogen comes here. 1 hydrogen comes here again. That's the H2S. So what type of bond that? Covalent. They are sharing.
Yes, they're sharing.
NH3 is also covalent. I've explained it before. So that's
Yes.
that. So why can never, in terms of this aspect, they can never jump this. They always give this question, identify the type of bond present. So let the student know how to identify the bonds that are present in them. And I wish you all the best for next term or next session as we begin to go into that term. So I think I can shut down now because I'm left with just a minute to go.